Okay, so good morning, everyone. I guess it's already noon, but okay. So we are here today virtually to discuss our previous task, which was task 5, and we were given different questions. And today we're gonna tackle all of those one by one. Now we will start with the first set of questions, which are mainly all about the elementary particles together with their symbols and their charges respectively. First, we're gonna delve into the definition of elementary particles. What are these elementary particles? So by definition, elementary particles are the most fundamental building blocks of matter, and they cannot be further divided into more compact parts. So it means that the composition, the structure of these such particles are final na, they are irrevocable, and they cannot, dili na sila ma-divide pa into mas gagmay na parts. So, sa akuan pa, it is what it is. Kung unsa to ilang structure, ilang composition, mo na gito siya. And they are called fundamental building blocks of matter because there can never be even energy, they are fundamental building blocks of energy. So they are called fundamental because there can never be matter, there can never be energy without these particles. And 'di ba, since in our high school and even in our senior high school years, we are accustomed ang ato ang nailahan lang ng mga particles, I mean, are katong mga protons, neutrons, electrons, which are still particles, but they are subatomic particles. But little did we know na apod ning mga elementary particles nga naay mga respective symbols, and also they have their own respective charges. Now, for the information of everybody, this is called elementary particles. They have naa sila yung mga types. They are divided into two main broad categories, which are the fermions and the bosons. And now this fermion, ipangalan siya after the Italian physicist Enrico Fermi, and ang bosons, pangalan siya after the Indian physicist na si S.N. Bose. And yeah, as I've stated, quarks and bosons, under ni sila sa broad category of fermion. And under po sa bosons, no. Okay, quarks and leptons are made up mo ni sila ang type sa fermions, and ang gauge bosons and scalar bosons mo ni sila ang part obviously sa bosons. And then as I've stated po earlier, na kani nga mga subtypes of elementary particles na po sila charges respectively and symbols po na i-discuss ni Francis.
So now let's proceed to the symbols and charges of elementary particles. So it is categorized into four, namely quarks, leptons, gauge bosons, and scalar boson. So quarks, it is the constituents of protons and neutrons, which includes up, down, charm, strange, top, and bottom. The symbol of up is U and its charge is positive two-third. The symbol of down is D and its charge is negative one-third. The symbol of charm is C and its charge is positive two-third. The symbol of strange is S and its charge is one-third. The symbol of top is letter T and its charge is positive two-third. And the symbol of bottom is letter D and its charge is negative one-third. So now let's proceed to the leptons. So leptons has six, includes electron neutrino, moon neutrino, tau, and tau neutrino. The symbol of electron is E negative and its charge is of course negative 1. Electron neutrino, the symbol is V sub E and its charge is 0. And moon, here is the symbol of moon, then its charge is negative 1. And moon neutrino, Here is its symbol, and its charge is 0. Tau, the symbol of tau is T negative, the charge is negative 1. And tau neutrino, V sub T, the charge is 0. Next is the gauge bosons. Gauge bosons has three particles, the photon, gluon, and the W boson. So the symbol of photon is Y and its charge is 0. The symbol of gluon is G and its charge is 0. The symbol of W boson is of course W and its charge is positive or negative 1. Then the scalar boson, which includes the Higgs boson, and here it is symbol of Higgs boson, and its charge is 0. That's all for the symbols and charges of elementary particles.
Okay, so that's for our first topic, mainly about the elementary particles. Now we will proceed to the value. Before that, do you guys have any um, additional ideas or clarification about the discussed topic? Lucelle?
Um, well, I also have the same idea with regards to the elementary particles as well as their respective symbols and charges, as what Francis and Julianne had discussed. So that is to say that elementary particles are basically the building blocks of matter, whose internal structure
Yes.
cannot be described as a combination of other particles, right? So, meaning to
Yes.
say that these particles are elementary in the sense that they are structureless and that they cannot be explained as a system of other particles. But I just have this question with regards to the two fundamental particles, the two broad classification of elementary particles, the fermions and bosons. So I just want to ask what is the main difference between these fundamental particles and what makes them different?
Okay. Okay, since it seems like it is under my scope, well, okay, so to answer that question of Lucelle, the main difference between bosons and fermions is that bosons are the carriers of the strong electromagnetic, weak, and gravitational forces. However, fermions are those that are fundamental units of matter. So basically, when we talk about bosons, meaning they are associated with forces. Kana sila ang mga nagdala sa strong, electromagnetic, weak, and gravitational forces. However, when we talk about fermions, they are those particles that make up matter. Maong ginatawag silang fundamental units of matter. So that was the main difference between the two, the bosons and fermions. Bosons mostly associated with forces, but fermions are associated with being the fundamental units of matter. And I hope I got to answer your question, Sel. Did I answer your question?
Yes, I. So that means that fermions are generally matter particles, while
Yes.
the bosons are generally force particles, right?
Yes.
Okay, thank you.
Okay. Okay, now we will proceed to the second topic, which will aim to focus on the value of the elementary charge, which will be discussed by Shiril.
The value of the elementary charge. What is the value of elementary charge? The value of elementary charge is 1.002 1766 times 10 negative 19 because the elementary charge usually denoted by E is the electric charge carried by a single proton, or equivalently, the magnitude of the negative electric charge carried by a single electron, which, which has charge negative 1A. This elementary charge is a fundamental physical constant equals 1.602 times 10 raised to the power 19 coulombs. To find the ionic charge of an element, you all need to consult your periodic table. On the periodic tables, metals found on the left of the table will be positive. The non-metals found on the right will be negative.
Okay, I guess that's it for the topic of value of elementary charge. We just have to take note that the general value of the elementary charge is this 1.6 times 10 raised to the power of negative 19 coulombs. We just have to remember also that this value is constant, and um, this value is known as the elementary charge, and by definition, it is a charge that a single electron carries, and it is a fundamental constant it is a fundamental constant as I've stated earlier, and it is the smallest amount of electricity. That is the elementary charge. Now, do you guys have further ideas or clarifications about this elementary charge? I guess that I can say that among all these topics, it seems like kani siya nga topic this is a topic that we are most familiar with, since it only deals with the constant value of the elementary charge. So we don't really need to dig much deeper into that, as long as we know unsa ni ang value sa elementary charge o unsa ni siya nga nagitawag siyang elementary charge.
That's correct.
Yeah, thank you for that. Now, okay, we will proceed. The quantized quantity, and how is it associated with our topic na charge? Unsa ang definition sa quantized, and unsa karon kung kabalo ta sa quantity, unsa ang iyahang connection sa charge? And
Now, Eman is here to delve into this. Eman,
So, good afternoon, everyone.
good afternoon.
Good afternoon.
I am Emmanuel Conanan, one of the presenter of this topic. So, in this time, I would like to tackle about the topic of quantized quantity. And a little bit, we are confused what really is quantized quantity. And this time, I would like to share my thoughts and ideas what is meant by quantized quantity. So, quantization is the concept that physical quantity can have only certain discrete values. And one of the examples of this are electrical charge, energy, light, angular momentum, and matter are all quantized on the microscopic level. And as you observe, one of the example is matter. So matter is quantized because it is composed of individual particles that cannot be subdivided and not possible to have an electron. So, and this time we have to proceed. Quantization is the concept that a physical quantity can have only certain discrete values. The basic elementary charge is 1.6 times 10 to the raised of negative 19 coulombs. And the amount of electric charge that can be observed is always an integer multiple of this fundamental unit. And if you saw in the picture, that would be the quantization of charge. So I would like also to share that the energy levels of electrons in atoms are quantized. The electron's energy can have only certain values, and all intermediate values are prohibited. So take note, the electron's energy can have only certain values, and all intermediate values are prohibited. Mathematically, this quantization arises from treating the electron's orbit as a standing wave, such that the orbit's circumference is equal a full number of wavelengths. So I would like to include also the we also see the quantization of charge in our daily lives, like the color of jeans, for instance. Um, that would be that. So thus, the rabbits are red because they have the atoms of chromium, whose energy levels are separated in such a way that we see in the red light. So that would be all.
Okay, thank you for the discussion about the quantization of charge. Okay, so if we would take it simply, the definition of quantized, pag mag-focus lang ka sa term na quantized, it means that it is confined to multiples of a tiny indivisible unit. So meaning, ang charge, napagit siya tiny indivisible unit nga mo na ang ginatawag natin na elementary charge. And this elementary charge, of course, as discussed, na siya specific value which is 1.6 times 10 raised to the negative 90 columns, and this is the constant one. Now, if ato siya i-multiply with either a positive and negative integer, mo na siya ang equivalent sa ato ang quantization of charge. That's why, if you express mathematically in quantization of charge, it is Q equals positive or negative integers multiplied by the elementary charge, which is 1.6 times 10 raised to the negative 19 column. So, more po siya idea about the notion that a charge is quantized. Now, do you guys have any other ideas other than that, or additional lang na explanation about the quantization of charge?
I actually have the same idea with you guys when you say when a quantity is quantized. Of course, this implies that a physical quantity must only have certain discrete values. And as an addition to what Eman had discussed, just from what I have read about the fundamental quantization, it says that explains that there are many natural phenomena in our surroundings that are quantized, and that explains why the appearance of leaves on a plant, or the dunes in sand fields, and even the waves on the oceans are all instances of this what we call quantization. So it results in an array of patterns and harmonies. So it is quantized because it can only be made of a number of whole waves. That is why we say that a quantity is quantized when a physical quantity can only have discrete values. So that is my idea about
Thank you. Yes, thank you so much for that, Marcel. And yeah, that explains more about the property of a charge being quantized. Now, to proceed, since we already know that one principle of one characteristic of charge is that it can be quantized. Other than that, charge is also conserved. And that's why we have the so-called hypothesis of conservation of charge. And Marcel will delve into this topic to give us more understanding about what this conservation of charge is. Marcel?
Okay, now the hypothesis of conservation of charge. So in the principle in physics, it states that the total electric charge of an isolated system remains constant, irrespective of whatever internal changes may take place. So basically, as from what I have researched myself, I have come to learn that the hypothesis or the main idea of the conservation of charge is that the total electric charge in an isolated system never changes. So, according to the law of conservation of charge, as we know, it states that the net charge of an isolated system will always remain constant. So, meaning to say that the number of electrons and protons remains equal, and therefore the net quantity of an electric charge, the amount of positive charge minus the amount of negative charge in the universe, is therefore conserved. Hence, the object with the surplus electrons will be negatively charged, and the object with the reduced quantity of electrons will have a positive charge. So that is the main hypothesis of the conservation of charge.
I just also want to add that this conservation of charge is under the massive umbrella of the universal law of conservation na we can also stumble upon if we will tackle yung sa mga motion and other physics concepts. This conservation of charge, under lang gihapon siya sa ginatawag na universal law of conservation. Now, as Nocel stated, it suggests that the system's overall charge is always conserved regardless of the factors that might affect it. And yeah, more gihapon, it's just the idea that the net charge of an isolated system will always remain unchanged. And okay, yeah, that's it for our discussion. But before we really end this, anyway, wala na additional information, guys, about or additional ideas about this hypothesis of the conservation of charge. Okay.
Eman.
None so far.
Okay, so
Okay.
we'll take that as a positive response, which means that we kind of took enough grasp of everything that has been discussed. But before we end this discussion, I would like to provide a brief recap of everything that has been discussed. So first, we delved into knowing what are elementary particles together with their symbol and their respective charges. Now, we were able to tackle that elementary particles are those particles that are fundamental building blocks of matter, and they cannot be subdivided into further compact parts. And it has two broad categories, which are the fermions and bosons. And under these broad categories, it also has a subcategory, which include in the fermions we have the quarks, and again these quarks are further divided into subtypes. And another type of fermion is the leptons, which also has a further subtype with respective symbol and charges. And we also have the second broad type of elementary particle, the boson, which also have further and further types, which are the gauge bosons and the scalar bosons. And under these two, they also have respective types, and they have symbols which are constant and charges also which are constant. And secondly, we also tackled the value of the elementary charge, which is again constant, the 1.6 times 10 raised to the power of negative 19 coulombs. And elementary charge, its definition is that it is the electrical charge that a single electron carries, and it is a fundamental constant and is the smallest known amount of electricity. And then furthermore, we discussed what is quantized, the definition of quantized, which means that it is to confine a certain quantity to multiples of tiny indivisible units, such as electricity. Since we already discussed that there is this so-called quantization of charge, which is anchored to the value of elementary charge, which is 1.6 times 10 raised to the power of negative 19 coulombs. And lastly, we discussed that one property of charge is that it is conserved. So that's why we have this hypothesis of conservation of charge, which generally just states that the total electric charge in an isolated system will always remain constant, regardless of the internal changes that may take place within them. So that's it for our virtual discussion for today, and I hope you guys had fun learning all this with the rest of the members as much as I had fun also. And yeah, so do you guys have any takeaways or final words before we end this?
I just want to say thank you, Jillian, for generalizing the whole discussion. I also think that this discussion was really interesting, and I have come to learn new things with regards to the past task about elementary particles and the charges and its various symbols. And then we also tackled about the quantized quantity, what does it mean, and the value of elementary of charge, as well as the hypothesis of conservation. So it is actually connected with our previous discussion. Um,
Yes.
so yeah, it's really amazing to know how physics actually work. And I think this discussion we were able to learn different things about physics. So yeah, I just want to say thank you. It was an amazing discussion.
Thank you also, guys. And this discussion wouldn't be realized without your efforts, without the cooperation of the rest of the group. And yeah, till next time, guys. Thank you so much and have a great day.